Now we're going to start covering quadratic inequalities. And this is going to be a reoccurring theme over the next couple lesson inequalities. We're doing specifically quadratic inequalities now. I believe next lesson we're going to do polynomial inequalities. And at the beginning of module 3, lessons 1 and 2, we're going to do rational function inequalities. They're going to progressively get a little bit harder and a little bit more complicated. But if you understand how to do quadratic inequalities, you're going to understand polynomial inequalities. And if you understand quadratic and polynomial inequalities, when we get to rational functions, you're going to understand rational inequalities as well. So let's understand this one when it is relatively easy. And then as we add on to it and get harder, it's not going to be as hard of a concept to understand. So example 6 says use the graph of quadratic functions to determine the solution. So we need to solve when f of x is greater than 0 and when f of x is less than or equal to 0. In general, these aren't always going to equal 0, but for us they will. And so remember, f of x is just another name for y. And so here we want to know when our y values are greater than 0. Well, I want you to pause this video and think about it until you have an answer or until you just don't have an answer. But pause this video and determine where on this graph do you have y values that are greater than 0. Okay. So I hope you've paused the video and you at least have an idea or you've thought about it. Where do I have y values that are greater than 0? Here is my y values here. Y values are greater than 0 above this x-axis. Here, all of these here have y values that are greater than 0. Okay. Once it goes above that 0, you've got 1, 2, 3, and so on. It's going to keep staying positive. So what sections of my graph have y values that are greater than 0? It's this little section here, and it's this section right here. Now this is kind of hard to determine because it's such a short little nub of a graph. But remember, as this is going up, it's also going to go out, right? It's also going to keep getting wider and wider and wider. And so when I have this little portion here, I start at that arrow. And so that's going to be negative infinity. And then it's going to keep going until right here. After this point, now it starts going below. So what is this point at here? That's at -2. And because it is greater than and not greater than or equal to, that will have a parenthesis. Then over here, as you go from left to right, at x equals 0, it's below. At x equals 1, it's below. Between 1 and 2, these are all below. But then once I finally get to x is 2, now it's on the x-axis. And as you keep going, it's going to keep going up forever, but it's also going to keep going out. So that is 2 to infinity. And when I have two different sections here, we will combine them with the u. So that's the union. So for this, we're talking about those x values because I'm already talking about the y, right? It already asked, when is my y greater than 0? Well, y is greater than 0 from negative infinity all the way to -2, and then also from 2, and then it's going to stay above to infinity. Now let's go the opposite way. Solve when your function is less than or equal to 0. So f of x is again another name for y. So when is my y less than or equal to 0? My y values are less than or equal to 0 below that x-axis. Now this one also includes when it equals 0. So that's that x-axis there. But we're talking about everything here on the bottom half of my graph. So where do I have y values here that are less than 0, that are negative? From when x is -2 all the way here to when x is 2. Now, because this one is less than or equal to, it does include these x-intercepts. And so these get brackets. We're going to do another example of this, in example 7. See if you can pause the video and see if you can answer example 7, and then hit play and we'll continue. Okay, so I hope you've had a chance to try to answer these. We want to solve when our function is greater than 0. So we are wanting to know when is our y greater than 0. Okay, so where's y? Where are my y values greater than 0, meaning when are they positive? That's everything here above that x-axis. So I'm going to kind of turn this page this time, but this is not including that x-axis. Everything in this section has a y value that's greater than 0. So what are the x coordinates, I guess? What's the x values that correlate when y is greater than 0? At -5, it's below. At -4, it's below. At -3, it's below. At -2, it's below. Here, at -1, it equals it. And then it's above at 0, 1, 2, 3, and at 4, it finally crosses, and then it's going to go below at 5. So it has x values from -1 to 4, make all of these y values greater than 0. -1 to 4. Because it's greater than and not or equals to, this will be parentheses. So now when is my y less than or equal to 0? This is essentially talking about the rest of the graph, right? Here's where my y values are less than 0. And this time it can equal. So we're talking about, I need a more dominant color, but that x-axis as well. So we have two sections here. This little nub again. So this arrow means -infinity to -1. Because it's or equals to, that's a bracket. And then the union, talk about this side here. At 4, you have your x-intercept. So at 4 with a bracket, because 4 equals 2. And then it's going to keep going forever to infinity.